welcome to another fun-filled day of verifying trigonometric identities. All right? So we're going to be working through quite a few problems. You might fall asleep a few times, but that's okay. You can always rewind this and pick up where you left off. All right? Now, by the way, whenever you're verifying these identities, you always start with the most complicated side and work your way over to the simpler side. So which do you think is the simpler side, Haley?
That would be my right side.
Yes, right here. This is the simpler side. So we're going to go from this to this. Now, by the way, these two things are rational expressions. They're fractions, okay? And whenever you're adding fractions together, what do you have to have? Common denominators is correct. So we're going to do 1 over the sine of y minus 1 minus 1 over the sine of y. Got it. It's a plus 1. What do you notice about these two denominators? This denominator is a little bit what? A little bit different than this denominator. So, here's what we have to do. We have to find a common denominator. So we're going to find a common denominator. I'm going to try to draw a relatively straight line. Oh, wow. That's horrible. Straight line. That's even worse. Third time's a charm? Hey, that's good. All right, so right now, look at this denominator. By the way, whose question is this? Whose question? Yours? Okay. So, awesome. What does this denominator need that it does not have? So we're going to write the sine of y plus 1. It has the sine of y minus 1, but it needs the sine of y plus 1. So we're going to put the sine of y plus 1 over the sine of y plus 1. What does this one need that it does not have? Sine of y minus 1 and the sine of y minus 1. Now, whenever you're doing this, realize this technically is equal to the number 1. All right? Whenever you're multiplying a number by 1, you're not changing the value, but we're just changing the way it looks. So let's think about what our final denominator is going to be. So we're going to make a better straight line here. So right here. What's our final common denominator going to be? It's going to be the sine of y plus 1 times the sine of y minus 1. That's our common denominator right now. Okay. So the next thing we're going to do is we're going to take this number 1 right here, and we're going to distribute that number to both numbers in the numerator. So what is the product of this times a 1? That's it. Because any number times 1 is itself. This is where you got to be careful of. You guys see this minus sign right here? Don't forget it. There's a minus sign. I'm going to do an open parentheses right here. Because now I have to take this 1 and multiply it to both numbers. So now we're going to get the sine of y minus a 1. Because 1 times the sine of y is the sine of y. 1 times the negative 1 is a negative 1. But I have to distribute that negative to both of those. So what's going to happen? This is going to become a negative sine of y. And that's going to make this a positive 1. So right now, take a close look at this, everybody. If I have a positive sine of y plus a 1, and I have a negative sine of y plus a 1, what's going to go bye-bye?
Sine of y.
Sine of y. Bye, sine of y. You're gone. But can I take the 1 and the 1 and add it together? Sure. So now what are we going to have now in the denominator? We're going to have a 2. All right. Now, we're going to look at something called the difference of squares. Now, the difference of squares is this concept. If you ever see a squared minus b squared, that always factors to a plus a b and an a minus a b. Okay? Now, it's kind of hard to see it. These are actually what's called a difference of squares. So when you multiply these together, it actually becomes sine squared y minus a 1. That's what it becomes. if we were to do the FOIL method, okay, it would work out to this right here becomes this right here. So this squared minus this squared. Now, everybody? And if you didn't know, if you didn't know that, what would you have to do? Multiply those together using what method? FOIL method. You have to FOIL it out. We're just going to this. If you do the FOIL method, it becomes that. Now, this is what I want you guys to understand. There's something called a Pythagorean identity. And this is the biggest step. Out of all the steps that we've done, this is where you need to understand you need to go next. So we're going to write the sine squared of y plus the cosine squared of y equals 1. That's what we need to understand right there. So right now, check this out. Hold on. What we're going to do, what is the sine squared of y going to equal? What would I have to do to solve for the sine squared of y? I would have to take away a cosine squared of y from this side and take away a cosine squared of y from this side. So technically, what is the sine squared of y equal to? It's equal to what? 1 minus the cosine squared of y. So through the process of substitution, I'm going to take this right here. And wherever I see a sine squared, what am I going to replace it with? I'm going to replace it with 1 minus cosine squared. So see if you guys, right now, see if you can see what I'm going to do. I'm going to go down a little more. So is the 2 change? No. What am I going to replace the sine squared of y with? 1 minus a cosine squared of y. And what else is right next to it? Minus 1. Ooh. You have a 1 minus a 1. So what does that become? 2 over a negative cosine squared of y. Alright, last step. You've got a 2. And you're multiplying it to a negative 1 over the cosine squared of y. I need you guys right now to look where your reciprocal identities are in your journal. Look for your reciprocal identities. This is one of the things you need to look at. You need to know that every time you see the secant of theta or the secant of y or the secant of x, that's always equal to 1 over the cosine of x or y, whatever theta is. Okay? So if the secant of y equals 1 over the cosine of y, what is 1 over the cosine squared of y? What is that going to be? Right. So this is going to be a negative secant squared of y, which becomes negative 2 secant squared of y. And what was the answer on the right-hand side of problem number 2? What was the answer on the right-hand side of the equation? Negative 2 secant squared y. So what did we just do? With all of this work, what did we do? We verified that this side indeed equaled this side. All right, problem number 3. In problem number 3, you need to remember from Algebra 2 the difference of 2 cubes. You need to remember how to factor the difference of 2 cubes. So what I'm going to do is I'm going to factor the special factors of a difference between 2 cubes, and it's going to be a minus b times a squared plus ab plus b squared. Those are the special factors for a difference of 2 cubes. Now, if this was a sum of 2 cubes, this would be the special factors for the sum of 2 cubes. You'd have a plus b times a squared minus ab plus b squared. So this is the sum of 2 cubes, and this is the difference of 2 cubes. Now, I'm going to color code this real quick. All right? I'm going to start with the left-hand side. Sine cubed of x minus cosine cubed of x. And I'm going to show you the special factors that go with sine cubed of x minus cosine cubed of x. So we're going to do two different colors. We're going to do blue. For everywhere I see an a value, I'm going to color it in blue. And wherever I see the b value, I'm going to color it in red. So hopefully you guys can follow the pattern here. This math's just about recognizing patterns. Here we go. Sine will be the blue, and cosine will be the red. So if this says a minus b, all right, we're going to have what? The sine of x minus the cosine of x. All right? So that's the first part. So we have the sine of x minus the cosine of x. So what will my a squared be? If a is the sine of x, what's a squared going to be? Sine. There you go. Sine squared of x. So I'm going to color it. And this time I'm going to do a what? I'm going to make sure I put a what? Plus, right? So put a plus. And what's my a value again? My a value is sine of x. So I'm going to put sine of x. I'm going to color it. Let's stay with the pattern. Now what's going to be right next to this blue? What's going to be right next to the blue? All right? So that's going to be cosine of x plus, what's going to be over here? I'm going to take something and I'm going to square it. So I realize I'm kind of on a line here. What am I going to put right there? Cosine squared of x. So now I have everything perfectly factored. It's pretty. Everything's colored. What's backwards? Now, everybody, we'll put a little star here. This is the most important part. You need to realize that you are dealing with a Pythagorean identity somewhere. It's hiding in plain sight. There's two culprits that are hiding somewhere. That's a Pythagorean identity. Aha! You found them. The sine squared of x and the cosine squared of x are hiding on opposite sides of the sine of x, cosine of x. But what do we know? That those are equal to. Can't hide from us. We know you two together, when you're added together, you equal a 1. So this and this together add up to 1. So let's see what we have left now. Okay? Would you agree we still have a what? A sine of x minus a cosine of x. But now, what did those equal? Those equal a 1 plus a sine of x and a cosine of x. Now, whenever you're multiplying numbers together, a times b equals b times a. 3 times 4 equals 4 times 3. So if I wanted to, I could say 1 plus the sine of x times the cosine of x times the sine of x minus the cosine of x. Would you agree that these two statements are exactly the same? All right? By the way, what was on the right-hand side of our equation? Let's look what we started with. The right-hand side. The right-hand side! Look what happened! We found it! Does everybody see how what did we just finish doing? We are done doing what? We're done verifying. We have verified it. What was the secret to this step? That was it. What would you have to find? What was the number one thing that was the hardest thing to realize? You had a Pythagorean identity hiding within your answer that you had to find. All right, problem number 4. Ooh. By the way, everybody, we're going to use some quotient identities right here. Quotient identities. So right now, does everybody agree that secant of theta is definitely the simplest side? Okay. So right now, I want you to look right now and look in your journal if you need to. Look for the quotient identity, not the reciprocal identity, but the quotient identity. Yeah, so here's what I want you to write. So instead of the tangent of theta, what I would like you to write right now for problem number 4 is the sine of theta over the cosine of theta. Write that down. Now we're going to add a cosine of theta over 1 plus the sine of theta. All right. Hey, come it. The denominators are not the same once again. These people are ticking me off. Now, Cartier, what does this denominator need that it does not have? This has the cosine of theta. This has 1 plus sine of theta. So this guy needs this guy. So you need a 1 plus sine of theta over here, and you need a 1 plus sine of theta over here. Now, I'm going to ask your cousin, Carter, what does this one have that this one doesn't? What does it need? That's right. Good job. Man, your cousin's way better than Cartier. Just kidding. Just one person. All right. So right now, does everybody see? What am I trying to find right now? What am I trying to find? I'm trying to find a common denominator. So here's what I want you to do. Let's write down our common denominator. We're going to make a nice straight line right here. Let's go ahead and put our common denominator together. Just don't multiply. Just leave it separate, please. 1 plus sine of theta is one of the factors. The other factor is the cosine of theta. So this is our common denominator that you're going to have right there. Okay, now let's check this out. In this problem, we have to take the sine of theta right here, and we have to distribute it to both values right there. So let's think about this. What is the sine of theta times 1? That just becomes the sine of theta. And what is the sine of theta times the sine of theta? Sine squared of theta. Now, by the way, every time I see a sine squared of theta, I'm hoping that there's going to be a cosine squared of theta so I can get that sucker to a 1. So every time I see sine squared of theta, come on, cosine squared of theta. So now, whoops, look at this. I've got a cosine of theta. And what do I have to multiply that to? Cosine of theta. And what does that give me? Thank goodness. Because what is this right here? I'm going to put a little arrow in blue. All right? Put it like this and this. This is very important because what do those added together equal? 1. So now you guys see how this is. How are we verifying? We're whittling things down step by step to verify. So now I'm going to write this. I'm going to write. What do we have in the numerator now? We have a sine of theta plus a 1. And what do I have in the denominator? I have a 1 plus sine of theta. Please don't be confused. Please don't be confused. Does everybody understand that if I said this is A plus B, this would be B plus A? And they're the same. Because you're allowed to switch things. All right? You're allowed to have what's called the commutative property of addition and multiplication. A plus B is equal to B plus A. A times B is equal to B times A. That's okay. These are still going to go, they're going to cancel to a 1. And so what do we have? We have a 1 over the cosine of theta. You have 1 over the cosine of theta. Now, what is 1 over the cosine? What do we have to look for? We have to look for one of our reciprocal identities. So when you guys are doing these problems and talking about them, what vocabulary words do I want you to use? I want you to use reciprocal identity. I want you to use Pythagorean identity. All right? I want you guys to use those vocabulary words. Just don't get, well, 1 over cosine theta, well, that equals secant theta. All right? Not that there's anything wrong with that. But to be more specific, say that, hey, 1 over cosine of theta is the reciprocal identity of the secant of theta. And by the way, what were we trying to verify? We were trying to verify that this side equaled this side. Okay? All right, everybody. Sometimes I'd tell my son this when he was a little kid. I said, hey, buddy, son, put your big boy pants on. Okay? So this is going to be a big problem. So right now we're going to be doing a big problem right here. Problem number 5. Make sure you have a full sheet of paper ready to go. All right, everybody. You might fall asleep at least 3 or 4 times during this problem, so make sure you drink some coffee before you start it. Okay? If you have an attention span of a gnat, drink 2 cups of coffee. Here we go. We're going to start with the secant of theta minus the tangent of theta, and we're going to multiply it to the secant of theta minus the tangent of theta. Because it tells us we're going to be squaring it, which means you're multiplying it to itself. So we're going to go ahead and do the FOIL method. This part's not going to take that long. The secant of theta times the secant of theta is the secant squared of theta. Secant times a negative tangent. That's okay. It's just a negative secant tangent. A negative tangent times a secant is another negative secant tangent. Notice I'm writing theta in there. Negative secant of theta. And then the negative tangent times negative tangent of theta, that gives me a positive tangent squared of theta. So what does that bring me to right here? I'll make a better nice line here. What does all of that combine together to equal? I've got a secant squared of theta. How many negative secant tangents do I have? I have 2 negatives, right? So 2 negative secant tangents. Okay. And then I have 1 tangent squared of theta. That's what I have. That's the first step. Just one. Just one tangent squared. Now, we're going to look at one of the Pythagorean identities that we haven't used today. So this Pythagorean identity, you'll see a tangent squared of theta, maybe plus a 1, and see what that equals to. Ah, all right. It is equal to secant squared theta. That's another Pythagorean identity. Now, that doesn't say tangent squared of theta equals, does it? Yeah. All right. So what I'm going to do is I'm going to take away a 1. I'm going to take away a 1. So what is the tangent squared of theta technically equal to? It's equal to the secant squared of theta minus a 1. So you guys see that right there? What I'd like you to do is I would like you to take this little piece of information right here. Okay? And I want you to substitute it for this guy right here. So substitute this for this. So instead of tangent squared theta, what are you going to write instead of it? Secant squared theta minus 1. So I'm just going to put a little arrow right here. I'm going to write, this means what? Secant squared theta minus 1. Now, look over here. How many secant squared thetas do we have now? We have 2. So I'm going to write, now we have 2 secant squared thetas minus 2 secant theta tangent theta. And I put a minus 1 at the end. All right, now, everybody, it's time to bring in some reciprocal identities. It's time to bring in the reciprocal identities. So, what are reciprocal identities? Here's one of them, ready? You know that 1 over the cosine of theta is equal to the secant of theta. All right? So if 1 over cosine of theta equals the secant of theta, I'm going to now replace this, and in the numerator there's going to be a 2. But in the denominator, you're going to write cosine squared of theta. Minus. There's a 2 right here. I'm going to put right now, I'm going to put a 2. I'm going to put over a 1. times something times something. Now, what is the secant of theta technically equal to, everybody? It's equal to a 1 over a cosine of theta. And now the next thing I'm going to do is what's called a quotient identity. This is the reciprocal identity. The quotient identity we're going to be working with is tangent. And tangent of theta is always equal to the sine of theta over the cosine of theta. So now I'm going to write sine of theta over cosine of theta minus. Now this part you might be confused, so I'll try to do this so that you guys aren't confused. You're like, aren't you just supposed to put a -1 there, Mr. Removed? I'm like, yes, we are. But technically, watch. What's the denominator? Cosine squared. What's this denominator going to be? Cosine squared. So what I'm going to do right here, everybody, is I'm going to write cosine squared over cosine squared. Why am I writing cosine squared over cosine squared? That's equal to the number 1. So go and write all of that out, and we're going to show you how to combine everything in the numerator and everything in the denominator. All right, so right now we're going to look at everything that's in the numerator, okay? So look at everything that's in the numerator. We have a 2 minus, we have a 2 times a 1 times the sine of theta, so that becomes -2 sine of theta. Now, don't forget, we have a minus a what? Nope. No, we're just leaving it. Just leaving it. Now, what's this all over? What's the common denominator that we found all the way across the bottom? Now, if you're not, like, wait a second, how in the world did you get that? Well, that's cosine squared theta. Cosine times a cosine is also a cosine squared theta, and then we change this to cosine squared theta. No. Now they would, if these were all, if this was all products, they would cancel out, but we can't cancel them out just yet. Okay, so by the way, everybody, this is what I want to see on your paper, because we are almost done. We're like so ridiculously close, it's crazy. So here we go. Now this is what I want you guys to write down. Write down sine squared of theta plus cosine squared of theta equals the number 1. Now what we're going to do right now is we are going to solve for the cosine squared of theta, which means I have to take away a sine squared of theta from this side, and I have to take away a sine squared of theta from this side. So everywhere you see a cosine squared of theta, what do I want you to replace it with? 1 minus sine squared of theta. I want you to replace it. So I'm going to highlight all the places that you can replace this with. Ready? Here we go. This right here is going to take the place, or substitute, using the process of substitution, it's going to substitute this right. Okay? And it's also going to substitute this right. So we have 2 minus 2 sine of theta minus, open parentheses, what am I going to plug in the place of cosine squared of theta? 1 minus sine squared of theta all over. What's going to go in the denominator right here? That's right. All right. Now, let's distribute. Now, when you distribute this, what does that become? That becomes a -1, and what does that become? A positive what? Sine squared of theta. Okay? So watch this. I want you to put the sine squared of theta up front. I want you to put minus 2 sine of theta right here. And then at the very end, you're going to put a minus a 1. So I'm putting the sine squared of theta up front, minus 2 sine of theta, minus a 1, and this is where your mind's going to be blown. Watch what I'm going to do to factor the bottom number. This is a difference of squares. A squared minus b squared factors to a plus b and a minus b. This factors to 1 plus the sine of theta, and this factors to 1 minus the sine of theta. This is a difference of squares. So if you're not sure what I just did there, I'll give you an example of a difference of squares. This factors to a plus b and a minus b. This follows the same pattern. Okay? Now, if you guys would please, wherever you see a sine of theta, I'd like you to replace it with the letter u. Wherever you see a sine of theta, I want you to replace it with a u. So here we go. Just trust me, it'll make more sense. So right now I want you to do u squared minus 2u. Hold on a second, I messed up. Oh wait, you know what? I forgot something here. You guys see the 2 minus 1? 2 minus 1? That should be actually a plus 1, sorry. Plus 1. There's a 2 right here. There's the minus 1. I forgot to do 2 minus 1 to make it a plus 1. So all you got to do is just make that a plus. You don't have to change anything drastic in your problem. Okay? All right. Now, by the way, does anybody know what this factors to? That factors to u minus 1 and u minus 1 and u minus 1. Why? Because negative 1 minus 1 more gets me a negative 2, and negative 1 times 1 gets me a positive 1. Now what's all of this over? This is all over 1 plus the sine of theta and 1 minus the sine of theta. So now that I have that factor, yeah, I gotta change them back. So what am I gonna, by the way, what am I gonna change this back to? I'm gonna change this back to, watch. Instead of u, what are you going to write instead? You're going to write the sine of theta minus 1 and the sine of theta minus 1. So here's what you have. By the way, we're so close. Yeah, you've been saying that for the past 5 minutes now. So right now, if you look very, 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 very carefully at this, you will notice that none of these things can cancel out just yet. Okay? Because is the sine of theta minus 1, is that different than 1 minus the sine of theta? Yeah, that is. And this right here does not, so nothing can cancel out. So here's what you're going to have to do. We are going to have to what's called factor out just one pesky negative. We're going to factor out a negative out of this expression. So if I factor out a negative, this is going to become a positive 1, because what's negative times a 1? A negative 1. And if I factor out a negative here, this is going to become a minus a sine of theta. So what's a negative times a 1? Negative 1. What's a negative times a negative a? Positive. So this is the most important step right here. The final answer. The most important step, what do you have to factor out? Yep. You have to factor out a negative. Okay? So factor out a negative, and right now you still have what? The sine of theta minus 1 over 1 plus the sine of theta and 1 minus the sine of theta. Now, what can we cancel out? Everybody see what we can cancel out now? We can cancel out this 1 minus sine of theta and this. So Emily, here's what you have. You have a negative sine of theta minus 1 over a 1 plus sine of theta. Well, look what happens when you distribute that back in. When you distribute this back in, what do you get? You get 1 minus the sine of theta over 1 plus the sine of theta. That's why I say get a whole page. Alright? So, after you're done, everybody understand, negative times the sine of theta, there's the negative sine of theta. What's a negative times a negative a? Positive. We just finished verifying that the left-hand side actually equaled the right-hand side. Last problem. Alright, here we go. Problem number 6. Once again, you guys notice this denominator and this denominator? They're not the same. So what are we going to have to do? We're going to have to find a common denominator. How about this? Why don't we just find the common denominator and just call it done? You guys have done this numerous times. What's going to be my common denominator between this and this? Do not multiply those together. Keep them separate, please. Just keep them separate. Okay? Now, over here, we're going to save you all a little bit of work. I'm going to have to multiply this guy by something, and over here, just pretend that he's not here. Okay? We're going to have to multiply the right-hand side by something. So, what am I going to have to multiply 1 plus cosine by? The sine of theta. What am I going to have to multiply the sine of theta by? So here's what you're left with. You multiply these together, and you have a what? You have a sine squared of theta. I like it. The sine squared of theta, all we need is what? 1 more cosine squared of theta, and we can make it equal to a 1, right? So this is going to be the harder part, okay? We have to do plus. We have to do 1 plus cosine of theta, and we have to do what with it? We have to make it squared. So we're going to have to do a little FOIL method over here, all right? So we're going to FOIL this out. So we're going to FOIL this out right now, so everybody can see what we're doing. 1 plus cosine of theta, and we have to FOIL it out. We have to do 1 plus cosine of theta. So let's go ahead and FOIL this out. 1 times 1 is 1. 1 times cosine is cosine. Cosine of theta times 1 is another cosine of theta. Ooh, and a cosine of theta times a cosine of theta gets us a cosine squared of theta. Now, by the way, before we get too excited, what do we have left? We've got a 1, we've got a what? We've got a 2 cosine of theta, and we have a 1 cosine squared of theta. So let's take all of this, everybody. Let's take all of this right here. Let's transfer it. Right. Got that down? Take that, we're going to transfer it over. Plus. What does that become? We have a 1, we have a what? We have a 2 cosine theta plus 1 more cosine squared of theta. And that's all over 1 plus cosine of theta, sine of theta. Has anybody seen the Pythagorean identities up there?
Yeah.
We got one right here, right? We got one right here. So what does that add to? A 1. Is there another 1 already there? So 1 plus 1 is 2. So here we go. We're going to put 2 plus 2 cosine of theta over 1 plus cosine of theta times the sine of theta. Does everybody understand how I got the 2? Because these right here became a 1, and 1 plus 1 is 2. Now, what's the common factor between a 2 and a 2 cosine of theta? 2 is right. So watch us factor out 2. Just so excited. We're going to factor out 2. 2 times what is 2? 2 times what is 2 cosine? 2 times? So we factored it out. Look what I have right here sitting, waiting for me in my denominator. This is exciting. Why is this exciting? Because what do I get to finally cancel out? 1 plus cosine theta. Phi 1 plus cosine theta. Whoa. Too fast. So what do I only have now in the numerator? What's the only number I have left? What do I have in the denominator? The sine of theta. Uh-oh, we're not done yet, because we have what's called a reciprocal identity. What is the cosecant of theta actually equal to? 1 over the sine of theta. So there's 2 of them, right? So this becomes what? This becomes 2. And there you go. And that's how it's done. So, that's right. Don't worry, people fell asleep at least 4 or 5 times. Okay? So what? By the way, here's all of the verification. Just try to follow it as best you can. Have a good day.